So you alluded to another layer of complexity in lymphoma biology that has emerged over the past several years as well, which is the epigenetic dimension. And perhaps spurred by the finding that many of the mutations that happen in lymphoma affect genes that regulate the epigenome, which essentially are the instructions or the software of the cell that provides the various programs that determine how cells behave biologically, both normal cells and tumor cells. And I would regard the discovery that these epigenetic mutations are a hallmark of lymphoma as also an important finding in the past 5 years. Maybe, Riccardo, can you expand a bit on how that plays into the why it's important and perhaps the therapeutic implications of that?
So the genetic lesions that have an effect on changing the epigenome, I think are extremely important for two reasons. First, they are very frequent in the most and recurrent in the most important, most frequent tumor type, follicular lymphoma, diffuse large cell lymphoma. And second, I think they are there's clear evidence that they occur early during lymphoma development. Maybe a third aspect, I think they are one of the roots that generates then follicular lymphoma or diffuse large cell lymphoma. So they actually gave a new view to the mechanism of transformation of follicular lymphoma. I think the word transformation should be reconsidered because the diffuse large cell lymphoma does not derive from a follicular lymphoma, but the common precursor has been identified, or at least on a theoretical genetic basis, that generates then divergent diffuse large cell lymphoma and follicular lymphoma. And the important point that that precursor clearly has two characteristics that are really recurrent, which is the BCL2 translocation, which is now targetable therapeutically, and one of the one or more of a genetic lesion changing the epigenome, which also may in the future be targetable, correctable therapeutically. So for me, that is one of the most important discoveries, if you want, in the biology of the most important lymphoma. And my personal view is that a lot of attention has to be given to the heterogeneity, to the evolution, to how the tumor diversifies, it progresses. But one should not discount what is really recurrent, these two lesions that are at the roots of both diseases and may in the future allow not only eradicate the tumor, but also prevents the so-called transformation into the more aggressive disease. So this to me has been a very important work.
And there are drugs that target the epigenome as well that may serve as precision therapies for patients that have these mutations. I wonder, maybe, Jude, do you have any perspectives on that aspect?
I think what's nice is we've got a kind of a good example. EZH2 mutations or gain-of-function mutations that affect a chromatin mark, lysine 27 trimethylation. It generates a kind of a repressive mark on the chromatin, and it's mutated in about 20% of the GCB type diffuse large B-cell lymphomas, and maybe about 25% of folliculars. And that's gone into clinical trials, and it looks like you're getting a preferential response in patients that have these gain-of-function mutations. I think the exciting work that you've completed in relationship to a link between, say, for example, HDAC3 and CREBBP mutations is also exciting. And as Riccardo has said, the frequency of these mutations are such that you're not looking at a small number of patients that can be potentially targeted, but quite a larger amount. I suppose what I'm interested in as well is the notion that you've got several different mutations affecting the epigenome. And the nature of research is you have to look at the effect of an individual mutation or an individual gene and what's actually happening. But a lot of our patients have 3 or 4 mutations in epigenetic components. And it seems sensible to think that, yes, they might have their own individual role, but they must be imparting or affecting a common mechanism as well. And I don't think that we quite know what that mechanism actually is. And it could be as simple as it's creating genetic heterogeneity at the expression level, so that within the CPC population you could have a large pool of cells that are all subtly different from an expression perspective because they're their chromatin landscape is different. And that in some ways kind of explaining the relapsing, remitting nature of FL, because the therapies that we have today aren't necessarily able to target that population. So I think that there's a lot to learn, but there's successes coming with the notion that HDAC3, EZH2, and new potential therapies that might target, say, for example, the more common KMT2D mutations. That it's an exciting time. But I suppose one concern, and I'm not sure what you feel, Ari, but it's possible that these alone won't be sufficient to actually change the clinical or the pathological landscape, that we'll need to work these epigenetic therapies in conjunction with a lot of other different treatments.
Oh yeah, I absolutely agree that single agents are unlikely to be curative in the long run, and we'll need to have combinatorial understanding of the complexity of the lymphomas. And that's starting to arise. I mean, there are now, perhaps one of the important findings in the last 5 years also is the ability to begin to generate rational combinations of targeted therapies that hit several pathways that are disrupted in lymphomas at the same time. Examples of that are combining drugs like ibrutinib that targets BTK, which is a kinase that is important for maintaining signaling activity in lymphoma cells, with drugs like that target BCL2, for example, in certain malignancies. And perhaps that is also starting to enable us to visualize a future where we might not need chemotherapy at all, or very little, as part of these treatments, and be able to perhaps sidestep the major toxicities that these cytotoxic drugs have. And there have indeed been recent reports of trials that have used, as per principle, a combination of targeted therapy drugs alone, even in diffuse large B-cell lymphoma, as an initial approach, and appear to be yielding significant clinical responses even before chemotherapy is added. I'm wondering if you can add your perspective to how we could get to the point of like a chemotherapy-free regimen in the future by understanding these pathways.
I mean, you're alluding to the SMART STAR trial, I guess, ibrutinib and len plus rituximab, and there are these anecdotal patients that get away without chemotherapy and being in remission. So I think that's the way to go. I think the most critical thing to do is, as you also mentioned, to have rational trial design. So I think these all-comer trials with targeted agents will fail. I also think adding compound X to R-CHOP in an all-comer setting is doomed for failure. We've seen Arnas's trial, now the Phoenix trial, where in the under 60-year-olds that were enriched for non-GCBs, he saw a signal by adding ibrutinib. I think you have to find the right population. So I think a person under 60 that's fit and healthy, you probably don't want to withhold the R-CHOP because you have such a high cure rate. But there are patients that are more complicated to treat, and those are the older patients that are non-high dose eligible in the relapse situation, or those that are not even R-CHOP or mini R-CHOP eligible in the frontline setting. So I think those would be prime candidates to be included into precision medicine trials. But again, I can only advocate not to go in an all-comer setting, but to really do the genomics properly, and then have multi-arm trials, for example, where you channel patients based on their genomic profile into certain intervention strategies. And I think there is plenty of evidence indicating that we may receive signal. I mean, there is the trial from Wyndham Wilson with ibrutinib in relapse refractory, very small numbers of patients, but interesting signal in the MYD88, CD79B co-mutated patients. So building on that and using that as a blueprint, I think, is the way forward. Finding the right patient population to treat, and I think it is, I think, relatively safe to start with those that are not R-CHOP or not high in the frontline setting, or not high dose eligible in the relapse setting, starting with those, and then and taking the genomics into consideration. The one thing to consider is toxicities. I mean, these novel agents, they're not free of toxicities, right? Ibrutinib is a compound that has toxicity, right? Particularly in the elderly population. So you have to be careful there, but still, I think this will be the way forward.
So I think in the UK, one of the big issues that we have is that the clinical trials are funded, but it's the parallel companion diagnostics and profiling and collecting tissue in a robust fashion as part of the clinical trial that probably isn't funded to the same degree. And I think that we're missing an opportunity by there not being a better relationship between the pharmaceutical companies and the academics in making sure that each trial not only is important for the trial at hand, but actually is collecting material in a robust enough fashion that you can go back and learn much more from those trials. Right. I think that's one of the significant changes that has to happen in the next 5 years, because then we're not having to repeat ourselves. We do things because material isn't available or the right material wasn't collected at the time that the trial started.
Right.
Yeah, I mean, I don't treat patients, so I look at feel. It seems to me that now that there are more drugs than patients to test them. So I think something has to be done in the whole well of designing the trials to treat patients. Huh?
That is an advance and also a challenge from the past 5 years, is the proliferation of new compounds. Often there are many compounds for the same target with different characteristics, and it is actually not possible to test all of them. Is there a better way? Is there a way to get to the clinic with the best? How do we? What do you think we've learned in the past 5 years that'll help us choose among all those possible, therapeutic targets?
Yeah, I mean, eventually you will have to have good preclinical models, right, to go into the trial with the most information possible in an in vivo system. So I think that is something that would be good. Trying not to use xenograft models or models that have a compromised immune system, but try to use autochthonous models with the compounds at hand. I think that will be useful and will probably increase the hit rate in the trials. But then eventually, there will still be failures of trials, right? Even if you have great preclinical data. I personally believe very strongly in genomic stratification. I think that is the way to go. And for many instances, I think you cannot come up with a good preclinical rationale that you validate, cross-validate also preclinically, to then go in with limited numbers of patients that are highly enriched for potential signal, and then take it from there. And I think that would be my recommendation. And I think in many cases, this is still not happening to the extent that I would like to see it. But I think we have tools now to more precisely stratify our patients. And you don't have to do exomes, but if you have a clever target sequencing panel together with flow or mass cytometry, I think you can actually nail populations that will then probably have benefit from the intervention that you do. That would be my recommendation.
So, and building on the same topic, certainly one of the most exciting advances in the past 5 years has been the development of immunotherapy approaches that are effective. After many years of promise and false starts, now we do have pretty amazing immunotherapy drugs. We have cell-based therapies with CAR T cells and other approaches. We have better antibodies. We have checkpoint inhibitors. And with that, for the immune tumors comes the interesting challenge of how tumors of the immune system might be affected by these therapies. Would it be dangerous to give T-cell enhancing therapies to patients with T-cell lymphomas? How well can tumors that arise from the immune system and therefore must by definition be able to hide from the rest of the immune system be amenable to these kinds of drugs and approaches? I wonder, maybe, Riccardo, do you have a view on the challenges and opportunities of immunotherapy for lymphomas?
For immunotherapy. So as you said, CAR T, one of the major advances. I think it's particularly suited for lymphoid malignancies because lymphoid tissue are renewable. So you can destroy the tumor cells and the normal cells, as CAR T do, and then they immediately renew. So it's a unique opportunity to develop new targets for CAR T. The success of in ALL is not replicated entirely in the more mature malignancies, so the search for new targets has to be there. The other major explosive area is checkpoint inhibition, inactivation, and that's a very complex area in lymphoma, at least in B-cell lymphoma. These tumors, a large part of them, hides from the immune system by preventing the exposure of neoantigen or mutant antigens. And so the relationship between this phenomenon and checkpoint inactivation is particularly complex, and probably our present knowledge of checkpoints is limited. A lot of emphasis has been on recognition by cytotoxic T cells, but NK cells are there, and a lot has to be, I think, studied to see how, for instance, tumors that don't present antigen are invisible to T cells can evade NK recognitions. And so that's an area, however, that I think holds great promise. Yeah.
From the standpoint of diagnostics, do you think we're at the point of being able to assign patients to immunotherapy based on characteristics of lymphomas that you can detect?
Well, these things have started to be explored. For instance, the expression, the levels of expression of PD-1, PD-L1 are starting to be incorporated not only by the expression of the protein, also the mRNA expression. So there are assays and proposals to start to incorporate. But whereas Riccardo was talking, I was thinking, I mean, I think you were the first showing that some mutations target exactly genes that are participating in the immunotherapy. And we are concentrating in the PD-1, PD-L1 system, but these tumors carry mutations in many other genes related to the immunomodulation. Not only mutations, also downregulations of certain recognition. So probably the identification, the more we know, probably we will need to better recognize what are the checkpoints that are altered in specific tumors, and how that could lead to a specific immunotherapy. Probably it's reasonable to think that that will be one way that will be incorporated in the diagnosis of the tumors to more precisely determine which is the immunotherapy that might be useful. As you mentioned, try to select the patient.
Because Riccardo, you identified CD58 and beta-2M as kind of key components, and TNFRSF14 is a kind of another mutation in these DLBCL and FL that clearly are important interactors. And I think Frida Stevenson showed the kind of the glycosylation status in relationship to somatic hypermutation is a kind of another potential means. Do you think that there's much more to identify, or do you think that it's a core set of key players that are actually making that effect?
I think there's much more to identify, and much more to identify not only on the tumor cells, but all the players around. I think in many cases right now, we don't even know whether the checkpoint inactivation acts on the tumor cells or some other player cells, in T cell, NK cells, others that have this. So I think the early clinical success as a sort of has to stimulate much more knowledge, because empirically they work. How they work, these new approaches, sometimes we don't know yet. So that's knowing that is a way to improve them. Yeah.
Very good. Okay, well, thank you, everybody.
Thank
Good
you.
discussion. Right.